we are back. Building the engine for the green car finally, and I have a bunch of stuff here and wanted to show you guys what's up. I've been collecting a lot of it over time. That's why it's been taking forever to get this done. And also, anyway, so I got broken pistons to show some failures. I have new pistons I'm not going to use because I don't like them. And then I have new pistons I am going to use that are actually really cool. And these I'm a fan of. So let's get into it real quick. We'll start from basically engine breakage to selecting pistons to, you know, going into what we're actually going to use for the engine. The 4.6 Ford, and a lot of cars, but specifically the 4.6 Ford is what we're talking about right now. The failure that happens on these cars when you boost them, a lot of times it has nothing to do with the piston melting or coming apart because of detonation or lean conditions, heat. It's usually not the case. It's not the piston that actually fails. What ends up failing is the ring lands because the ring closes its gap. So basically, if we look at this piston, this came out of a 2001 Cobra, stock piston. The ring gap is, I don't know how well you can see that, but it's this space right here on the ring. And the ring gap is designed to, you know, like close up combustion pressure to the top. It doesn't let it go through. So if you didn't have rings, you'd have obviously a ton of blow by. And the ring gap is supposed to be as tight as possible, but it needs to be able to expand because as things heat up, you know, the ring will expand and it'll start to close the gap. So what always happens on these engines is when you boost them, you create too much heat and the ring gap actually closes. And when the ring gap closes, it breaks the side of the piston off, or it breaks the ring itself or the ring land itself. And that's like 90% of the time the failure that happens on boosted stock 4.6 motors. That's what's happening. So it's not the tune, it's not the piston that's weak. You know, yeah, you upgrade the piston, but when you upgrade the piston, you're building a new engine, and you're probably going to cut the rings for boost, so you're going to expand the rings a little bit more. But it's not necessarily the piston that's the weak component in the car. If you remember the Mystic, we were doing 600 horsepower in it all day, every day pretty much, spraying it with nitrous, had boost behind it, and it was just taking it left and right for a couple years. And it was using your standard, what's called a 4032 casting piston. So what is 4032? You got 4032 and 2618. 2618 is this kind of piston. So when you're looking at a forged piston, you're usually talking about a 2618 piston. This is a incredibly dished piston. We're not going to use this, obviously. But 2618 is like more of a pure aluminum mixture. The 2618 and those numbers dictate basically the formula or the recipe in the casting of the aluminum. So this aluminum piston, back in the day, they didn't have silicone in them and they were a lot weaker and they couldn't handle as much heat. So they added silicone. So these pistons, 4032 pistons, have anywhere between 12 and 16% silicone content. The reason being is because you can run tighter cold start tolerances. And this is actually a harder piston than this is. A lot of people get that confused. This piston is basically a harder material than this piston. The way to look at that is if you think about an impact socket and a chrome socket. The impact socket is actually a weaker socket than the chrome socket. The chrome socket's far more strong, far stronger. The reason for that is because if a chrome socket breaks, it shatters. And if you're using an impact on it and it shatters, it's basically like, you know, a danger. The impact socket will actually just tear itself apart because it's a softer material. And the impact socket, if you look at them versus a chrome socket, the wall on the impact socket is far thicker than the wall on a chrome socket. It's because it's a weaker casting. Now, that's just a concept that has to do with the tooling. But this concept of why you would do this is because this 2618 piston can actually deal with more heat than this piston can. But if you detonate on either one of these pistons or have any pre-ignition issues, you're gonna blow the oxide layer off the piston and you're gonna melt it anyway. But these pistons do have a better quality for higher boost. The reason that they're made a little bit softer is because they can actually flex and deal with more pressures, because the piston, instead of snapping off or breaking apart, it is actually able to kind of you know, manipulate itself in there, and it's just a softer material, so it can deal with those pressures. Imagine like soft suspension, right? So that's why you would use this kind of piston. Now, I am not using this type of piston. I'm not going to go with a 2618. I'm still sticking with a 4032. So why would I stick with a 4032? So if we look at right here, it actually says forged 4032. Those are the pistons that we're going to use. The reason being is because these pistons, being that it's a softer material, actually wear out far faster than these pistons. That's why OEM uses a 4032 piston, because the silicone protects this aluminum so well, and it's a harder piston. These last so much longer. So at what point do you want to go with a 2618 forged piston? Once you get to a certain level power-wise, you will eventually have to go into a stronger piston. Drag racing applications, you know, just high horsepower applications, they are a good option for that, specifically because you need it. You know, you're going past the heat tolerances of your, you know, your 4032, and you end up having to go into what this piston is required for. Now, where's that ceiling? On the Ford motors, honestly, I wouldn't be putting this piston in the car until I was making 800 plus. That's a lot of juice. And it depends on which, you know, how much cylinder pressure you're creating based on what type of supercharger you're using, what kind of turbocharger you're using. Cylinder pressure has a lot to do with that, and then also how much heat you're creating. That is why I run an EGT system on the car, because I like to know exactly the temperature of the gas coming out of the motor, so I know what I'm looking at in terms of piston safety. So we'll look at this piston real quick. This is the one that actually came out of the green car. If you remember the video a long time back, we had a blow-by issue. It was very easy to diagnose. We pulled off the valve cover cap, and then it was blowing out a bunch of oil and pressure, so we knew there was blow-by. Why there was blow-by? You know, oh, it's a failed piston, which it was, but, you know, a lot of people assume that the piston melted because of a lean condition or something like that. No, it's not that at all. It actually is just the rings weren't cut for boost. Somebody tuned it as if it was tuned just straight for boost. It generated too much heat. The ring gap closed, and when the ring gap closed, it shattered the ringland, and then you're left with no way to seal the piston, because now you've got broken rings, and you end up with a bunch of blow-by. The piston itself, the sealing of it, the top that was dealing with all the pressure and everything from the boost and all that, that's survived. That's fine. It was the ring gap. So my point in that is, if you took this piston out of that engine, took the rings out, shaved the rings and filed them for boost and put everything back together, this piston would have survived just fine. That's what I did on the Mystic with the cheap pistons I ran. They were $300 set of pistons, similar to these, but when you order from certain companies, you know, their house piston comes from different locations, different manufacturers. So now we're going to get into kind of like what you're looking at when you're buying and selecting pistons. So that was kind of a failure issue there. And then also we're upgrading the rods to Coyote rods. These are the old style cracked metal rods. So these ones there, it's actually like they cast it as one piece and then they snap it. And it's a powder metal rod, very basic, but you can buy Coyote rods. They're pretty much the only thing available nowadays. Far, far better rod than this one. And they're, you know, cheap. They're like 250 bucks for the set of rods. All right, now let's start with, we got some engine bearings. So again, we're talking about different companies, right? Different distributors. So, you know, when you're buying parts, what are you looking for? And basically the bearings are pretty much similar, right? Like there's not a lot that goes into the bearings. There are different layers in there, and there's what's called embeddability, which I have another video on YouTube about embeddability in bearings. So we're really not going to try and get these mixed up. But what I liked about the King bearings is, one, it's just a high quality bearing material. They do guarantee a very high accuracy, and it also comes with a new thrust washer, so we can you know, actually have options when we're doing the thrust washer on the crankshaft. And this one, basically, you'd put the old thrust washer back into place. So these, we're not going to use these. We went with King bearings, which is awesome. The piston rings themselves, these are a basic set of rings, and I would be completely fine using these. But I decided, after seeing the pistons and upgrading the piston from this set, I went ahead and upgraded the rings to a stainless steel ring. So it's a different type of deal. So again, this is stuff that we're not going to use. And then now let's talk about the pistons that I basically ordered, got in, and decided I didn't like them. So these are a set of D&J, just cheap. It's cheap material, man. It really is. And so now let's look at the difference. So these are probably, oh man, I don't know, I think it was like literally a third of the cost of the DSS racing pistons. Still a 4032 piston, as the DSS are. But the casting of these, it's just, there's a lot of like really thin spots, and you can actually see this one cracked and chipped off a section right there, just from shipping. And it's just, it's a weak piston material. So when I got these in and kind of saw them and held them in my hand, I was like, no, we're not going to use these. Now, would they work for an OEM rebuild? Yeah, but when we're going to start putting some boost to it and everything else, I don't have the confidence in these that I had in the original pistons that I used in the Mystic, which again, they're both from ModMax Racing. They're both ModMax's house piston, but the ones that I bought previously came from a different manufacturer, and it was just a better piston. And they survived like crazy. And again, cut the rings well, the piston will survive. Will this piston do it? Honestly, probably. I wouldn't be too terrified of this piston. You know, you could, you know, when I built the Mystic originally, I was like, I'm just going to see what happens. And so I was building stuff with, you know, an open mind of this thing can easily come apart. And it never did, which was cool. Until way later, where I really fucking, excuse it, really hammered into it with some nitrous. And then it was expected. It was basically a planned failure. So now let's look at the difference between this set of pistons and the DSS racing pistons. Again, 4032 silicone piston, but they are quite different. So first thing we're going to start off with is the difference in this wrist pin. So if you can see up close on that, difference in size, I did get this out so I could show you. So this is our wrist pin from D&J. And we're looking at 3.8 ounces, okay? And then this is our DSS wrist pin, 4.3. So that's a big difference just right there. And this is just, I think this is a better material too, than this one is. I don't know what kind of casting this is. I could call DSS and get their, you know, get the type of wrist pin material that this is. But this is just a better material. Now, let's go into piston design. So these pistons were 6cc dished, but you can see they're cut for a 3-valve motor. They will work in a 4-valve car, no problem. But that's where you're getting that extra cc, which quite frankly, like if you're getting it just from that, you're not really getting the extra cc's from a good design for burn and, you know, piston head design. Whereas these are 10cc dished, and you can see it's a very clean design. It's actually the whole dish of the piston comes down, and it's just a really good piston for that. And then again, the cleanliness of these, it's just, you can see that it's a far better piston. So this is a forged piston technically versus this one, which is like straight cast. So you can see here, you can actually see the sand material from the casting. So basically they make the casting, you can see all the sand and everything, and then they take a machine and they cut off the excess. So when they do the casting, the top isn't shaped like this, and then they shave the top to fit the size of what they're looking for, and they cut the crown, they cut the ringland area, they machine all that off. Whereas this one, the casting is, I believe these are pressed basically, like it's a stamp, and then you're left with this really, you know, it's a different piston design, and then they cut it out. So it's comes out of more of a stable piece of material basically. And again, this is still a 4032, so it's silicone based versus our 2618. Now, let's take a look at the actual piston design. If you look at the difference between the thickness of material here and here, the skirt is far thicker. You've got the wrist pin section of the piston, which is, they're trying to save as much material as possible, versus this one where they're giving you extra material so that you can, one, balance it because you'll probably take material out of these edges, and then two, you're just getting so much more strength here. And then also, this has an oil feed hole that comes in through the side of the piston here, whereas this one does not have an oil feed hole, and it's expecting extra splash up from the crankshaft to land into these holes, and that's what's going to oil the wrist pin. So this one's designed a little bit better to feed oil into the wrist pin and everything. And then now let's check the weight of these. So you want to check it with the wrist pin in it, because that's what the piston's going to be. So we're talking about 1 pound, 0.1 ounces. And then this one, we're looking at 1 pound, 1 ounce, 0.1. So this is an ounce heavier than this piston. So that makes a big deal. A step I refuse to skip is, which we're going to the machine shop tomorrow with everything, is to balance your rotating assembly. When you're balancing the rotating assembly, you're basically weighing out the entire reciprocating mass, which is going to be your piston, your wrist pin, your rod bearings, your rod, and the rings and the clips that hold in the wrist pin. And you're balancing all of that to the counterweight on the crankshaft. So as the crankshaft rotates, it's like balancing a wheel. Like, you wouldn't put tires on your car and not balance the wheel. You feel the shake in that. So imagine what your engine feels if you don't balance your rotating assembly. So I basically refuse to assemble an engine without an internal balance. Very excited for these again. Very strong pistons, 10cc dished. Very satisfied with these. They are a little expensive, but this time around on this build, we're not really going to be taking risks like we did on the Mystic. We're going to build it for functionality and success. So now let's drop into some other parts that aren't piston based, but they're, you know, things that go into building the bottom end, the short block. So we're going to put these pistons away, and that was a nice lesson for y'all. So I went ahead and spent the extra money, I guess, to teach y'all not to buy those, I guess. I don't know. I'm not here trying to tell you not to use those. It's just different pistons for different applications. Super high horsepower, nice expensive forged pistons, 2618s, will wear out faster than a 4032 piston. For less horsepower, which is what we're gonna be running, I'm expecting to hit somewhere around 600 wheel. We're gonna be using the DSS 4032s, and they should handle it just fine, and we should be good to go. So the one failure that we did have on the Mystic was right when we started hitting 600 horsepower at the wheels, the heads started to stretch themselves off of the block. So the heads started to uninstall themselves, basically. And that's from head bolts. So when we built that motor, I used Felpro head bolts, $40, no big deal. And eventually that's what was not working anymore on the car. So this, we're going with ARPs. I don't really have to get into this because y'all know what this is, but you know, it's a, oh my God, 40, I forget the steel designation, but, oh, anyway, it's chromoly steel, very, very strong, studded. It does change, what I wanted to talk about with this is it does change the clamping pressure on the block. So you have to torque plate the engine with these studs in order to get the hone and the bore correct. So these are 20 thousandths over pistons. So we're gonna recut the block. You have to torque plate it with the hardware you're gonna use to assemble it, because the aluminum and the steel sleeve will actually flex differently based on the clamping pressure of the different hardware. It's very minimal, but if we're trying to do things really right, it's the way to do it. And you're gonna buy them anyway, and you gotta pay for the bore job anyway, so you might as well just do it right. So anyway, waited for these to come in, got those, so we're gonna send those to the machine shop. And then these are the rods. Super cheap, super easy. It's just a set of Coyote rods. The machine shop will have to match this brass bushing to the wrist pin for the piston. And then they'll balance these to, they balance and make sure all of these weigh exactly the same, and then they balance the crankshaft for that. So, to close this video up, what are we doing when we go to the machine shop? What you want, you know, if you're building a short block for a motor, what do you need when you go to the machine shop? So, for balancing, we need the rods, we need our pistons, because they're gonna balance all of these, and then they have to have the weight of that. On top of that, we need to have the rod bearings, because the rod bearings are on the crankshaft as it rotates, so that's part of that rotating assembly. And the counterweights have to be taken into account for that. Your rings are also on the pistons, so those have to be taken into account for. And then the clips are inside the piston box. So this should be everything you need for balancing the rotating assembly minus the crankshaft. Rods, pistons, rings, bearings. And the pistons have the clips and the wrist pins and all that in there already. We are using the factory style main bolts, because that's not really a failure point on that motor. So that does not need to go to the engine or the machine shop. The rod bolt or the head bolt or head studs need to go to the machine shop because they have to torque plate the engine when they do the bore, and then the block. So basically, this is your stack when you go to the machine shop to do a short block. Hardware for your heads, the entire section for the rotating stem to do the balance, and then a crankshaft and your engine block. And then with all that, you give it to them, you throw them some dollars, they hand it back to you, and then when we get it all back, I'll show you how to put all this together. So that's pretty much it. If you have any questions, hit me up, leave a comment, you know, subscribe. I'm trying to get back into the flow of things. And then when we talk about building the short block, we'll talk about, you know, cutting rings, and I think I have a video on that. But we're gonna go from scratch all the way through this whole build on this car, and the process hath started. So there you go. Hope you have a good night, good day, good life, and stay happy.